Hey math friends, we are going to be looking at exploring ratio concepts. This video will help us with Monday's lesson for understanding ratio concepts, our assignment. So our learning target is understanding the concept of a ratio and using ratio language to describe a ratio relationship between two quantities. So this should sound very familiar to what we worked on in Edgenuity. First, we're going to start here by warming up our brain. We're going to be looking at these pictures here and think about how we can write about them using ratio language. So here we have an example. There's 4 controllers and 1 screen. So the ratio that I can say is there are 4 game controllers for each screen. Now for these, there's different ways that we can think about it. So on this first example, we can say that there's 2 boxes for every so many crayons. So we're talking in terms of boxes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 crayons. That's one way to write the ratio. Or we can look at it as an equivalent ratio or groups. So I can see that for every 1 box, there are 4 crayons. Oops, 4 crayons. So that's just a simple way to write what we're seeing in pictures. Okay, now the next one, we normally, when we talk about mittens, we think of that as a pair. So I can see that here we have a matching one, and a matching one. We have a group. So for every, I can write it like this, for every 2 mittens, there is 1 person. Or we can look at it as an equivalent ratio where we're looking at a group. So we can look here. We have 1, 2, 3, 4, 5, 6. For every 6 mittens, there are 3 people. And I'm just trying to write this quickly, so I apologize for the messiness. But now that we've gotten to think about ratios with pictures, we're going to go ahead and look at ratios as numbers. So in this lesson, we're going to be using models and numbers to talk about ratio concepts. So here we have 2 tables. So you can either look at it this way, like a ratio table. If it's easier to see it this way, like that, that's how a ratio table would be drawn. Or you can just look at it as a group of values. Okay, so I'm going to look at this first scenario in A, and all my x values and my y values. So I see that my x values are going up by 1. I'm going 1, 2, 3, 4. And in my y values, I see that we're going 3, 6, 9, 12. And that to me looks like it's going up by 3. So I'm noticing some patterns. Here it's going up by 1. Here it's going up by 3 each time. But what I really want to notice is what's happening between x and y. I'm looking for the relationship between these 2 values. I'm comparing them. So let's look what's happening between these numbers. How does a 1 change to 3? How does a 2 change to 6, 3 to 9, and 4 to 12? Well, that looks to me like a multiplication problem. I know that if I multiply 1 times 3, I'll get 3. And if I multiply 2 times 3, I'll get 6, and so forth. So I can see what's happening here, that the relationship or the pattern that I'm seeing is that I'm going to be multiplying by 3. Now I'm going to do the same thing over here. I want to kind of try to see the relationship between these 2 values. So just like before, I see these ones are going up by 1. That's good to notice. And I also see that these are going up by adding 3. But I really want to pay attention to the relationship between the values. I'm comparing them. So here I can see that it's going this way. I can multiply by 3, or sorry, yeah, multiply by, oh, not multiply by 3, get this erased. I'm not multiplying because my values are getting smaller, they're decreasing. Like, so here it's decreasing to 1, this is decreasing to 2, this is decreasing to 3. So I can see that we are actually dividing by 3 instead of multiplying. So if I did 3 divided by 3, I would get 1. 6 divided by 3, I would get 2, and so forth. So it would just keep going down. So what's happening down here, the pattern, is that it's being divided by 3. Now my next question for you to look at, are these ratio tables the same? Are these the same ratios? Well, let's look at this very first one, and I'm going to circle it in green, 1 and 3. Are these the same ratios? A lot of people would say yes, because they have the same numbers. There's a 3 and a 1 and a 1 and a 3. But if we look at it a little differently, if we say x values are triangles and y values are squares in both circumstances, and we draw them, we model our math, we can see something very different. So on the A side, it says that we have 1 triangle for every 3 squares. Then over here on the B side, it says that we have 3 triangles. Oops. Let's put this guy in the middle. For every 1 square. Now looking at these, I can see they're not the same because I have 3 triangles and 1 triangle. They are not the same ratio. Okay, so it's important to look at the order in which your ratios are being displayed. Okay, also make sure to stick with your unit. So this is a square, this is a square. So when you're drawing your model, you have the right things going on. So how are we using ratios to compare quantities? Well, we use ratios, models, and tables to look at what's the same and what's different. How are we dividing things? How are we separating things? Models and numbers really help us to compare quantities. So let's look at this first example. You can use multiplication as a way to compare two quantities. So we're looking here at A. In Charles's lab group, there are 4 times as many test tubes as students. So there's my ratio. I'm just going to go ahead and highlight that because that's my ratio that it's telling me. There are 4 times as many test tubes as students. That's the main number that I need to be looking at. Complete the model to show the comparison. A circle represents a student and a rectangle represents a test tube. So here we can see that same ratio. There are 4 times as many test tubes. So 1, 2, 3, 4. And then there's a student. So that's my complete ratio is 4 to 1. Now if I look over here, I can see that I'm missing something. I need to complete my ratio. So I see there's still 1 student right here, but I need to have 4 test tubes for every 1 student. And the same thing is true right here. To make that ratio complete, I need to make sure that I have 4 test tubes for every 1 student. Now looking down here at B, it says 1 more student is added. So 1 more student, here's our student, is being added to the group. How many test tubes do I need to have to include the model? Or if I see here, I already have 1 circle, so that means I need to draw 4 test tubes to complete the model. And voila. So how many more test tubes do I need? I need 4 test tubes. Okay, and looking at this same thing is we can use a ratio to compare 2 quantities. One way to describe a ratio relationship is to use the language for every or for each, like we did earlier on. We were talking about the mittens and the game controllers, okay? So in Eldora's lab group, there are 3 test tubes for every 1 student. So there, I see my ratio, 3 test tubes for every 1 student. And I'm going to go ahead and write that. So 3 test tubes for every 1 student. And I can see that ratio is right here. It's been started for me. So what I need to do is I need to make sure that I show the right amount of test tubes. So it tells me here test tubes is 3. So I need to show 3 test tubes for every 1 student. I already have the 1 student here, so I'm just going to go ahead and complete my pattern here. My ratio is really a pattern in comparing numbers. So now that I've compared and completed my pattern, my model, I'm going to go ahead and look at this part too. It says use your model to complete these sentences that use ratio language. So for every 1 student, there are how many test tubes? Well, here's my student. I see that I have 3 test tubes. So I'm going to go ahead and write 3. Now the next thing it says is there are blank test tubes for each student. So there are 3 and 1. Now it's going to ask me to talk about the ratio in terms of student. So I know there's 1 student for every 3 test tubes. Okay, and here's our last problem that we're going to look at together. The Spanish Club's having a party, and they plan on serving 6 tacos for every 3 guests. So here is our ratio. Okay, so we have 6 tacos for 3 guests. So I have my ratio. Now I need to complete my model here. Okay, first I'm going to write my ratio. So it says that I have 6 tacos for every 3 guests. Okay, so I'm just going to go ahead and write 6 tacos. 2, 3, 4, 5, 6. 6 tacos. Then when I look back at my ratio, it says I need to write 3 guests. So 1, 2, 3. So now I've completed my model. Now I'm going to move on to B. It says use ratio language to write 2 different sentences that compare the numbers of tacos and guests. So here's where we're going to be using for every. So for every taco, there's going to be a guest. And for every guest, there's going to be so many tacos. Okay, so I know for every taco, there's going to be so many guests, right? So I can just go ahead and look at my values here. So for every 6 tacos, there's going to be 3 guests. And for every 3 guests, there's going to be 6 tacos. That's one way to write it, okay? Now it says, Julong says that there will be 2 tacos for every 1 guest. Use your model to help explain why Julong is correct. So Julong is correct. So we know that 2 to 1 is an equivalent ratio. Let's see why. We're going to go back up to our drawing and we're going to say, okay, Julong, they said that there are 2 tacos for every 1 guest. So I'm going to circle 2 tacos and put it with 1 guest. 2 tacos, 1 guest. 2 tacos, 1 guest. So yes, I can see that that's right because this is an equivalent ratio. If I just separate it to have these guys go together, it's equivalent to our original ratio. This guy over here. Okay. In our assignment, we're talking about the word compare. So I want you to explain how we compare numbers, how we compare numbers together, how we compare with pictures, how we compare with words. So what is comparing? Tell me, what is comparing to you? What do you do when you compare something? That goes here. What do you know about comparing? What kind of questions do you ask yourself? How do I compare the size of this circle to this circle? What words can I use? How can I show comparison between 2 things? So you're just going to go ahead and this is actually on your assignment. So you're just going to use this to help you fill that out. If you guys have any questions, please shoot me a message in Canvas and I would be happy to help you. Again, this is for the lesson on Monday for understanding ratio concepts.